Hello everyone, welcome to She Drives Data's Statistical Analysis with Excel sessions. So today we're going to talk about descriptive statistics. So what exactly is descriptive statistics? It is nothing but a summary of data. It is used to simplify data using certain indicators. The summaries can tell us information about data before formal modeling and hypothesis testing and all those other tasks. So today we're going to see how we can get this information in Excel. We can either use Excel formula or we can use analysis toolpak in Excel. I will just give you a demo of how to install the analysis toolpak. Now this is our data file. You need to go to the ribbon and click on the data tab and go to this analysis option, data analysis option. But this tool is not pre-installed in Excel. You need to install it. I'll just show you how. Go to file, go to options and go to add-ins, and you can click on this little option here and then click OK, and you will get this data analysis toolkit right here. So either you can use this, or like I said, you can use a formula, the formula bar. This is the data I got from the website Kaggle, and this codebook describes the data. It describes each of the columns individually and the type of data and the scale, the range, etc. And the creator of this data is Mitesh Kumar Singh. And this is I thought this is a fun data set to start with because it has Bollywood and it's very informal. If you want to download this workbook, you can use the link given in the YouTube description box. Now see, this is the IMDb ID of each of these movies. The release year is given here, the release date, the genre, writers, actors, directors, whether the movie has a sequel or not, the number of sequels, and the hit flop indicator is given here. And if it's 1, it's a disaster, 2 is given as flop, 3 is below average, 4 average, and so on, and 9 is all-time blockbuster. So here the columns are called variables, and we can either individually analyze these variables or we can analyze 2 or more variables together, right? So today we are going to analyze each variable individually. That is called univariate analysis. Yeah. So I'm going to choose the hit flop indicator for today's session. There are several ways to conduct a univariate analysis, right? You can use the central tendencies like mean, median, mode. You can use distributions like range. We can find the frequency distribution, kurtosis and skewness. And you can find the dispersion of the data like the variance, the standard deviation, etc. So first let's go for a simple frequency distribution. So I want to find out how many disasters were there, how many flops, how many below average, how many all-time blockbusters, etc. I want to see the frequency of each of these numbers 1, 2, 3, 4 up until 9. So I'm going to use a COUNTIF formula for that. For COUNTIF range and this is my criteria, and I'm going to lock this range. Right, frequencies. I'm going to just highlight this. Yeah, and we have the frequencies right here. So now let's just plot it onto a graph. We're going to calculate this, select this, insert. Yeah, we've put it in a chart, and this is our frequency chart, right? Yeah. Now from this chart itself, you can infer quite a bit. For example, the maximum number of movies in this data set are flops, right? There are around 729 disaster movies, 257 flops, etc. Right? I'll just move this chart here. And now we need to drill down to get further information about this variable hit flop. So for that, I'll click on the data tab and I'll click on the data analysis. Now select the descriptive statistics option and click OK. Now you need to select the data. Select like this. Labels are in the first row, the label of the variable. And I need to create a new, I want this information in a new worksheet. So I will put hit flop univariate analysis hit flop. So I want summary statistics, confidence interval, right? Largest, smallest, click OK. So we have this information in the next sheet. Now range is the maximum value in our in this variable minus the minimum value, that is 8. Minimum value is 1 and maximum is 9. Sum is the total sum of all our data points. Count is the number of data points we have, the largest and the smallest. Now let's look at standard deviation. Standard deviation is the square root of variance. Now what is variance first of all? Variance is the average of squared difference from each data point to the mean. So we take the square of each the difference of the mean and each data point and then average it out. The standard variation is the square root of the variance. It is a measure of how spread out the data points are. If the standard deviation is large, it represents a very spread out data points. So in our case, it is 1.8, right? It's not too low, it's not too high either. So in this case, even if we just look at the chart, we can see how spread out the data points are, right? This is the frequency, but instead of frequency, what if we just take the scatter plot. See, in this case we can see the spread of data points. Is it too closely spread out? No. Is it too far away? No. Right? So the next indicator is variance. We've covered that. It's the squared average distance between the data points and the mean. Now what is kurtosis? Kurtosis is a simple measure of the distribution of the data. It is set in terms of the sharpness of the peak. A positive value shows your distribution has heavy tails and the negative indicates light tails. To check if the distribution is normal or close to being normal distribution, you just have to see if the kurtosis is 3 or close to 3. So what is our kurtosis here? It is 1.9. It's not exactly 3, so it can't be a normal distribution. The data is not distributed exactly normally. The next measure we're going to check is skewness. What is skewness? Skewness is a measure of distortion of the symmetrical bell curve of our data. How distorted the bell curve, if we make our data set into a bell curve, how distorted it is to the left or to the right. If the skewness is positive, the right tail of the bell curve is longer, and if it is negative, the left side is longer. Mean and median will be less than that of the mode in the case of a negatively skewed data. Now let's go through each of these characteristics individually. So first is, this is arithmetic mean. So what does an arithmetic mean indicate? A mean points to the central tendency of a given set of numbers. It is the most commonly used number to summarize the data. However, when we examine data for insights or while we develop strategies, relying on this particular number alone can be disastrous, even though it is convenient. Now let's look at why this is the case. Now, in the case of mean, outliers can significantly vary the mean. It does not capture the range or spread of the mean, that is, it does not give us the full information. A single value does not inform the uncertainty involved in the scenario. So it's unwise to only focus on the mean of a given data set, even though it's convenient and it is quite useful. So in our case, the mean is 2.14. Let's take it as 2. What is 2? 2 is an indicator of flop movies, if I'm not wrong. Yeah. So a mean is concentrated on the flop movies. Now, what about median? What exactly is median? Median is the middle value of the data set. We can classify the series of data into two categories, above and below the midpoint. In that case, we get an idea about the range, the upper limit and the lower limit from the number. It is not affected by the outliers or dense data points on either side. That is the advantage of median. When the data is incomplete, it is best to use median and not mean. But what are the disadvantages of using median? However, it is the main advantage of data is split into two. It can also mislead our way into thinking about its nature. When our data is continuous, a median does not imply grouping of data into two, type 1 and type 2, or high and low. The data is flowing gradually and median is just a middle value. So what are the solutions? Now, splitting data into 3 or 4 groups can help us see the data more than just in a black and white. In the case of median, we are splitting into 2, right? But if we split it into 3 or 4 groups, we can see the spread of the data more clearly. And in such cases, you can also concentrate more on what each portion of the data is talking about and not treating all values within the group as equal. Now in our case, median is 1. Now mode, what is mode? Mode is the largest occurring data point in this variable. So here, clearly, what is mode? 1. The number of disaster movies is the mode and its indicator is 1. So do visit our Sheroes community and subscribe to our channel for more updates. You can also visit our website www.shedrivesdata.com. Now this is the confidence level. We've set the confidence coefficient to 95%. A 95% confidence level shows the level of faith we have in the survey. If you repeated the survey over and over again, 95% of the time, the results will match to the actual population results. Now looks like we missed one indicator, that is the standard error. So what is a standard error? A standard error measures the accuracy with which the sample represents a population. So here this is our sample of Bollywood data, right? A population is all the movies ever released in Bollywood, and we have a sample of 1285 movies in our data set. Right. So as what does a standard error represent? It measures the accuracy with which the sample is represented. Was our sample collection good? Does it represent the population? Now thank you for watching our video on descriptive statistics. Now if you have any doubts or any other suggestions, you can come to our community at the Sheroes app. We discuss a lot of data science, machine learning, statistics, maths, etc. Want to download this PowerPoint and the dataset? It's always available in the Google Drive. I've given the link in the description portion. So subscribe to our channels for more update and come visit.